So what is Python? So Python is a programming language that can be used for all sorts of purposes, ranging from the development of desktop applications to scripting to automate some tasks, or developing apps for mobile phones, tablets, or even scripting web pages. It is interpreted and not compiled. Examples of interpreted programming languages include Python and MATLAB. Whereas compiled languages, examples include C, C++, Java, and so on. In general, the compiled languages run faster than the interpreted programming languages. So what is an interpreted programming language? So if you look at the Python code I'd shown before, when you execute this code in Python, what the Python interpreter does is it sees this first line and it assigns 20 to variable x. That's what the line of code asks the computer to do. Then the second line asks the computer to assign 0.52 into variable y, and then it does it. And it goes to the next line and assigns this variable into this, and it keeps going line by line, performing the commands in each line of code. So each line of code gets interpreted and the requested instruction is executed. Whereas in compiled programming languages like C++, if this were to be a C code, all of these lines of code will be saved into one file, for instance, and that file could be testing.c. Then you will pass that testing.c code through a compiler, and the compiler will end up generating code in machine language, and that machine language code will be executed on the machine directly. It's not a case of interpreting each line of code line by line. So that's the difference between interpreted languages and compiled languages. So in Python, there is no compiler, but there is a Python interpreter, which basically interprets the code line by line. The advantage of interpreting code line by line means you can change a code you already executed before and then evaluate the new line of code which does something a little different. And that allows interactivity. So Python is interactive, meaning you can run code segments and obtain results on the fly. Whereas in compiled languages, you will need to, if you make just a small modification to one file out of 100 files, which total 100,000 lines, you will have to save that file that you changed, the one out of 100 files, and then compile all 100 files again, generate new machine language code, and then run that, and you will now observe what the change was. So it's not interactive. So that's why Python is used a lot in prototyping code. What that means is you're just trying to test out an idea. So you can do it on the fly interactively. When it works and then you want it to be very fast, then you go implement that algorithm in a compiled language like C++, Fortran, Java, and so on. Python is intuitive and concise. It's intuitive, meaning you can just look at the Python code and figure out what it does from the function names and the way it is structured. It's concise, meaning you can achieve a lot with just one short function call. One concise command does so much. It's object-oriented, and we will talk more about object-oriented programming later, but the general idea is object-oriented programming allows you to design your code in an organized or modular format. Whereas in procedural programming, you basically will call functions one after the other. Python is dynamically typed. What that means is, like you saw before, x can be set to 2, which is an integer. Y can be set to 2.5, which is a real number. Z can be set to Mike, which is a string. But you can do this in statically typed programming languages. So programming languages that are not dynamically typed don't allow this. The compiler will need to know what type of variable you want to store in the variable, what type of value you want to store in the variable. So you will need to declare the type of these variables before trying to store anything inside them. And that's variable declaration. So you will need to first say variable x is an integer type. After that, then you can say x equals 2. You will need to say variable y. Basically declare variable y as being of a double point floating precision type, and then you can store a floating point in it. You will need to say Mike is a string, Z has to be declared as a string before you can store a string in it. So this is what you get in languages that aren't dynamically typed. But in dynamically typed programming languages, you don't need to declare variables. You can also come back here. You already stored an integer into x. You can later store a real number inside that same variable. The Python interpreter is able to figure out the data type of this variable from the value you store in it. And that's what dynamically typed programming languages mean. So why use Python? Python is free. The Anaconda Python you will be using in this course is all free, and everybody loves free stuff. The commercial programming languages, say MATLAB, for instance, can be expensive. So having all of the functionality of Python for free is one of the attractive features of the language. It's easy to learn, easy to program, easy to debug. It's modular and object-oriented, like I explained on the previous slide. It requires minimum time to develop and maintain because the language is intuitive, like I mentioned before. It has a large user community. Why is this important? It means you can easily find solutions to problems you run into because other people have run into similar problems before and they posted the solutions on the internet. Several free Python packages exist for statistics, visualization, modeling, and for so many different purposes. Whatever you're trying to do, someone might have done something similar already. So you need to check out the packages, the Python packages that may be suited to whatever programming objective you're trying to achieve. So these are the reasons why we use Python. Some of the Python packages we'll be using for statistics are shown here in relation to the core Python distribution. The core Python distribution contains only the key features required of any general purpose programming language. On top of the core Python distribution, you have the numeric Python, which is what NumPy is, and it has data types for like matrices, vectors. It also has functions to facilitate calculations, operations on those data types, so operations like matrix vector operations, dot product, and things like that. They are all built into this free package. All the packages that are distributed that we will be using, they are all free. They come just like Python, they are all free. And on top of that, we have SciPy, which is Scientific Python, which is based on NumPy. It uses NumPy. We have Matplotlib, as the name suggests, for plotting 2D plots, 3D plots. You can create them using data in Python. Pandas basically allows you to do things, the operations you will typically do in spreadsheets. So the Pandas data frame looks just like your cells and rows in Excel. Seaborn also is built on this, and Seaborn is for statistical plots. They have statistical models, multivariate linear regressions and stuff. You can see those in Stats Model package. On the left, we have the IPython, which means interactive Python. And then we have Jupyter Notebook, which is built on top of the interactive Python. So you will see that the Jupyter Notebooks we'll be using are stored as IPyNB. And that means interactive Python notebook. I'm not going to talk much about this because you can simply follow these instructions if you want to install Python on your computer, or just Google how to install Anaconda Python. Right now, I think the latest version is 3.8. So you can grab that. It will still work with all of the labs we will be doing in this course. But the computers you'll be using in PFT 2243 all come with Anaconda Python pre-installed. And that will be it for this class. Next, we will talk about the labs.